All right, guys, are there any questions over any of the assignments thus far?
Yes.
Which one?
I think yesterday.
You're welcome. The assignment for yesterday is on page 113, problems 3 through 12. 3 through 12. Now, what we're looking at today is we're continuing with solving quadratics. Now, we've done a little bit of solving in 3.13, where we did the factoring and setting it equal to 0, because that's one way to solve quadratic equations. Because we can solve it by factoring. Write the polynomial equation in factored form and then solve by the zero product property, and we've done that. Now, what we're looking in 3.3 is solving it by graphing and using the square root method. These are the two we're going to be looking at in 3.3, so today and tomorrow. Now, the first one is graphing. And if we graph the function, we want to find the x-intercepts. And the x-intercepts are going to be the value of x that makes the function equal 0. Because that's what we're really trying to find when we solve. We're trying to find what values of x are going to make the function equal 0, or the x-intercepts. So, the first thing we want to do is graph this function here. We're going to solve it by graphing. And up to this point, whenever we graphed a function, so if we were graphing the equation of a line, we needed 2 points. Because if you're graphing the equation of a line, you need 2 points. For graphing a parabola, we really need the vertex and 2 points either side. If we know what the axis of symmetry is, we really just need the vertex and 2 points to the left or to the right, because they mirror each other. But what we can do is we can actually use the graphing calculator. Because if I have the equation of the parabola, or this equation here, I need to make sure it's set equal to 0. That's one of the first things we need. So here it is set equal to 0. We have x squared minus x minus 6. So we can use the graphing calculator. And the first thing we want to hit with the graphing calculator is the y equals. Y equals. And if we have something there, we can clear it out. Now we want to type that function in, x squared minus x minus 6. So the button right next to alpha will give us x. Then we can say squared minus x minus 6. Any questions on this so far? Were we all able to type the function in? X squared minus x minus 6. Yes. You can go on and hit enter once you get it typed in. So the square button is there. Now the little caret key, I call it the caret key, the button above the division sign will also do exponents. So if we're looking at an exponent other than 2, we can use it to do thirds, fourths, fifths, sixth powers. And what are we wanting to do? We're wanting to what? Is there a button that lets us graph? Yeah. We can hit graph. And I have a feeling you have a window that looks a little bit different than mine, yes? It actually makes a U. Now, for some of these here, because this is set a little differently, if the window doesn't look right, we can do zoom 6, zoom standard. And I think you got something like this here. Yes? Now, the points where it crosses the x-axis are our solutions, because we're looking for what values of x will make the function equal 0. What will give us a y value of 0? Now, it's kind of easy to see these two here, but what we can do also is say second graph. Second graph will give us a table.
I click graph and then it just shows the line.
So we can go zoom 6.
Oh, thank you.
Zoom 6 is zoom standard. So the plot up here, hit enter. Any questions on this so far? Okay. So we're wanting to find what? What value of x will make the function equal 0? What's going to make the y value 0? Yes? So what are our two spots? 3 and -2. Because again, we're wanting to see what's going to make the y value be 0. So we have two spots. So here, you might have to scroll up or down, but we looked at the graph, there's two places that it crossed, yes? And with most, all of our parabolas, there's going to be two places that it crosses. There will always be two solutions or no solutions for a quadratic. It's either going to cross the x-axis or it's not. If it doesn't cross the x-axis, we'll get to it eventually, but we will still have two solutions. They just won't be real. Every quadratic will have two answers. They might not be unique answers because we could have x is equal to 4 and x is equal to 4. It could have a repeated, but there will always be two. And here our answers are 3 and -2. So for this here, the solution is x is equal to 3, comma, -2.
So whatever makes y equal 0 is the answer to the question.
Yes, and we could check this here because I could take 3 and say 3 squared minus 3 minus 6. I'm plugging 3 into the equation because what we're looking for is what value of x is going to make this be 0. Well, 3 squared is 9 minus 3 minus 6. 9 minus 3 is 6, and 6 minus 6 is 0. The other number we had was -2. -2 squared minus 2, -2 minus 6. Well, -2 squared is 4. -2 is going to be plus 2 minus 6. 4 plus 2 is 6, and 6 minus 6 is 0. With all the ones that we have here, when we solve it, we can plug it back in to check to see if it is the right answer. Because if it's a solution, and we have the equation equal to 0, x squared minus x minus 6, if we plug it in, it should give us 0. Questions on this one here? Let's look at the next one. -2x squared minus 2 is equal to 4x. What do we? Let's look at, so what do we need to do first? What did we need these equal to? Is this equal to 0? Because -2x squared minus 2 is equal to what? So to get it equal to 0, we need to subtract 4x from both sides. Because before we can graph it, we need this equal to 0. And if we subtract the 4x over, we get -2x squared minus 4x minus 2 equals 0. So, any questions on how we got this equal to 0? Now to graph it, so we can hit y equals. Now, if you want to clear this out, we can hit clear. Negative 4, let's see here, negative 2x squared minus 4x minus 2. Yes. Because the number or the sign in front of the 2 has to be negative. Just question?
Did I do that right? Oh, look at me go.
Mm-hmm.
Okay, so it is -1.
There we go, minus 2. There you go. But they're not, this one here does have 2. They're just not unique.
So mine has this, but I no. Oh, clear that.
Mm-hmm.
That's clear. Oh, thank you.
Mm-hmm. So, where is it equal to 0? At -1. Now, there again, with any quadratic, we will have 2 solutions. One of these for this here is -1. The other solution is -1. Because here, where does it cross or hit the x-axis? At -1. Anytime it touches the axis but does not cross it, there's 2 zeros there.
Wait, so the reason there was 2 different, first one is because it went all the way up?
Mm-hmm. It went through. So here, the solution is -1. And what we call this is an even multiplicity. Anytime there's an even number of zeros at that spot, an even number of solutions at that spot, it won't cross. It'll touch the x-axis and go back down. But that's it. Questions on this one here? We ready for the next one? Is this equal to 0?
Yes.
So that means we can type it in. So we can go y equals x squared minus 8x plus 12. And we can hit graph. Plus 12. Mm-hmm. X squared minus 8x plus 12. Mm-hmm. Number 1.
After that, you hit second graph.
Oh, I put 2 instead of 12.
And we can go second graph. And our values are 7 and 6. Because again, we're looking for what value of x is going to make the y be 0. We're looking for what value of x is going to make y be 0. So x is equal to 2, comma 6. We could say x is equal to 2 and x is equal to 6. Either one of these works. Because we're not looking for the point, we're looking for what value of x, the x value, we can list it this way. Because if we were asked for the x-intercepts, we need it as 2, comma 0 and 6, comma 0. We need it as the point. Questions on this here? Let's look at the next one. 1 half x squared equals 6x minus 20. What do we need to do?
Hold on, say the equation. No, the last one. I'll ask.
No, I just got confused with these two, but I just mix them together.
Okay. Because it's better to ask questions now. So, what do we need to do first with this one here? What?
Equals with an alpha y equals
Yes. So what do we need these equal to? 0. So how can we get this one equal to 0? Subtract what? Yeah, we can do subtract 1 half x squared from both sides. These will cancel, tell me 0 is equal to negative 1 half x squared plus 6x minus 20. Now, when we worked with factoring, we wanted the term in front of x squared, the variable with the biggest exponent, to be positive, yes? Because then it's easier to work with. Does the graphing calculator really care? Well, no, we can make it negative. So on the graphing calculator, we can hit y equals.
Hey, I want to tell this thing.
Okay. So, guys, let's focus up here. So we need to put in this function. So the first thing we have is negative 1 half, yes? So what is 1 half as a decimal?
0.5.
So we can do 0.05 if we want. If we want to put in a physical fraction, we can say alpha y equals enter. And we can say 1 over 2 x squared.
Alpha.
Y equals enter.
Oh, mine doesn't do. Yes, it does.
Green button.
I pressed it.
the green one. I think it does. I got it.
It doesn't do anything.
I'm not stupid.
I think I got it.
We just need the 1 half to be
Yeah, it's not working for me, but
negative.
Oh.
Yep.
Oh, yeah,
I'll have to update
yeah.
the programming on it.
Forgot about that.
Most of them I've got to update to the correct program, but
Boy, it has to update too.
yeah, they push software updates for some, and some of them don't have it.
mine's not.
But I can get it updated for free. It's a little bit of a process, but I can get it there.
Oh, update math.
Yours has it. It doesn't have math print, which lets us do the fraction.
So you should not be able to do fractions.
These didn't.
I have it.
So we can hit graph. So negative 0.5
just put negative 0.5. Negative.
x squared plus 6x minus 20. So where does it cross the x-axis? So for this one here, we have no
Okay, I'm not gonna
no real solution.
We're seeing it coming.
There is a solution to it,
Like mine's
but it's not real. And we will get to those eventually. But since it doesn't cross the x-axis, it's not going to be easily attainable by graphing, or attainable at all by graphing.
That means like you can make it 0. Hey, on the next one though, there is no like.
So let's look at any other questions on this one here before we look at the next one. Let's look at this one here. So this one here is already equal to 0, so we can go on and graph it. So we can say y equals. We can clear that out. 4x squared minus 12x plus 9. We can type that in, and once you get it typed in, go on and hit graph. So,
But there's not a zero. There's not a.
so it does hit the x-axis, yes? But does it hit it at a nice whole number? Well, it's somewhere between 1 and 2, yes? So the graphing works nice if it's at a nice whole number, positive, negative, that's kind of nice. And if it actually hits the x-axis. So graphing is nice, but it does have limitations. Because if it's a decimal, we have to go and figure out what it is. Now, for this here, because well, it works out. The value for this here is 1.5. Now, I know that from just working it out. But for some of these here, like this one, most likely we would go with factoring. Because then we can go and factor it and try to solve it that way. Because here, we could factor this equals 0. Since the third term is positive, the signs are the same and they match the sign of the middle term, which is negative and negative. The factors of 4x squared are going to be 2x and the factors of 9 that we're going to use are, and if we check this here, 2x times negative 3 would be negative 6x. Negative 3 times 2x is negative, which gives us negative 12x. So here we can add 3 to both sides, telling us 2x is equal to divide by 2, so x is 3/2 or 1.5. So for some, graphing works well, but for others it doesn't. So for this one here, it's going to be a little bit more helpful for us to go by factoring. So factoring works well if it is a rational number. If it's a rational number we can write as a fraction, we can solve it by factoring. If it's an integer, graphing works very well. But if it's not an integer and it's not rational, neither one of these work. So graphing works well some of the times. Factoring works well some of the times. We will eventually get to some methods, 2 methods that work every time. Any questions on these so far? Let's look at the next method, which is the square root method. The square root method works very nicely when there is no middle term. If there's not a middle term, or we have a set of parentheses squared, we're going to use the square root method. So when we look at this here, we don't have a middle term. We don't have x to the first power. We don't just have an x without an exponent, yes? Whenever we come across these, we can get this so the x squared is by itself. Whenever I don't have a middle term, I try to get the x squared by itself. So what's the first thing we can do here? Because I want to get x squared by itself. When we have no middle term, we get the x squared term by itself. Or if we have a set of parentheses squared, we get it by itself first. So negative 31 plus 31 is 0, giving us 4x squared. Then what can we do next to get x squared by itself? And if we divide both sides by 4, 4x squared divided by 4 is x squared. 20. And this is what makes the square root method nice, because now I just have x squared by itself. That's the only variable. How can we get rid of the square? So what is the method that we're using? So we need to, because what's the square root of x squared? Now the square root of 20, and this is where the TI-30XS, the other yellow calculators come in nice, is because they will simplify radicals for us. Yep. And whenever we square root both sides, we have to put plus or minus. Plus or minus. Because whenever we square root something, we're trying to find what x is. Because if x is, well here, 2 squared of 5, if we square it, we get 20. Because 2 squared of 5 times 2 squared of 5 is 20. If it was negative, well, the negative times a negative is a. So the answer, whenever we take a square root, is the positive or negative of that value. And that's it. Questions on this here? Now, whenever we don't have a middle term, or we have a set of parentheses squared where x, the only x is inside those parentheses, we can use this method here. We get the term that has that variable by itself, square root both sides, and solve. So if we look at this here, 3x squared minus 9 equals 0. So we could try typing it into the graphing calculator and graphing it. If it gives us whole number answers, it works out nicely. If it doesn't, we can use the square root method because there is no middle term. Now, if we use the square root method, we would add 9 first because we want to get the x squared by itself, which will tell us that 3x squared is equal to, yes. Which tells us x squared is equal to, what do we do next? We square root both sides. Square root of x squared is equals plus or minus. Can we take the square root of 3?
It's 1.73205.
No. So we'll leave it as a square root of 3. Square root of 3. Because there's not a nice number that multiplies by itself to give us 3, so we'll leave it as this here. The yellow calculators will simplify that as far as it'll possibly go. If it doesn't, it'll leave the radical there. Any other questions on this here? Let's look at this next one here. Now, when we look at this next problem, it is a little bit different than the one we just did. But what we have is a set of parentheses squared. There's no other x term. So what we can do with this here, we can still use the square root method, but what we're going to do this time is get this set of parentheses squared by itself. Because, guys, focus up here. If we can get that set of parentheses squared by itself, and I take the square root of it, the square root and that square would cancel. So what we can do first is what? What do we need to do to get the set of parentheses by itself? Well, we can multiply by 5/2 or divide by 2/5. Because if I divide this by 2/5, divide both sides by 2/5, these will cancel. Now we could have multiplied it by 5/2. Because 2/5 divided by 2/5 is 1. Now on the other side, we can have alpha y equals enter. Well, second quit. Alpha y equals enter. 5 over alpha y equals enter. 2/5. And it'll simplify to 25 over 2. Now that we've got this set of parentheses by itself, we're going to square root both sides. Because if we take the square root of something that's being squared, the square in that square root will cancel out, leaving us with x plus 3. We don't. I just left them there. So we could drop the parentheses at this point. Now we do need to simplify the 25 over 2. Now in the yellow calculator, we can take the square root of 25 over the square root of 2. We could type that into the calculator and let it do it. And again, this is also kind of nice having both calculators because both of them will work these. The graphing calculator was just going to give you a decimal. And if we type this in,
Oh, you do it separate.
yeah, because in the yellow calculators, we can do it separate. You'll need to do it separate for the yellow calculators.
Top and the bottom.
Mhm.
Oh,
Because if we do it separate, we would get 5 over the square root of 2. And to rationalize that, we get 5 square root of 2 over 2. Now, we didn't really need these here. Is x by itself? Is x by itself? No. So to get x by itself, we're going to subtract 3 from both sides. And here, 3 minus 3 is 0. And that tells us x is equal to. We want to put that 3, whatever we add or subtract at this point, in front of the plus or minus. So we would have negative 3 plus or minus 5 square root of 2 over 2. And on the ACT, you're allowed to have both calculators. You can have the graphing calculator and the 30XS. You just can't have them on the desk at the same time.
so like I just switch.
Yeah, so you can, that's ACT.
I'll put it
That is whack.
Yep. So if you need to switch between the two, it's just putting it down on the floor and picking the other one up. But really, at this point, for a problem like this here, guys, did we really need the graphing calculator at all for it?
No.
So we could have put that on the ground, used the other one for it. Any questions on this one here?
ACT because it's a bunch of word problems. And like if I knew how to break the word problems before, I could figure out which method I have to use.
All right, guys.
That's why.
Let's look at this one here. 2/3 x squared plus 14 equals 20. So if we wanted to, we could get this equal to 0 and see if graphing does help. Now for here, let's go on and use the square root method. So the first thing we want to do is get x squared by itself. So minus 14. Which will tell us that 2/3 x squared is equal to
6.
Yes. Now what do we do next?
Square root, right?
Is x squared by itself?
Oh no, I have to divide by 2. I just saw
So now we need to do 6 divided by 2/3. 6 over 2/3 gives us 9.
Hey, that's a nice number.
Mhm. What do we do next? Square root both sides. The square root of x squared is? X is equal to plus or minus 3. So again, we got to remember whenever we take the square root of both sides, we need the plus or minus. So it's plus or minus 3. Any other questions on this here?
No, I actually get it. Don't tell them I'm gonna have to use the plus and minus.
Do we have any other questions on a problem like this here?
Y'all understand this?
Yes, you just move this -6 to the other side, put it equal to, and type it into your
Okay.
right?
So we can add 6 to both sides. Negative 2x squared plus 7 is equal to
0. Oh, I meant.
y equals negative 2x squared plus 7. And we can graph this here.
Look, guys.
Does it cross at nice points?
Yes. Yeah-ish.
Well, it's crossing between 1 and 2 and negative 1 and negative 2.
Not really.
So
you can
no.
use square root.
So we can use the square root method.
Yeah.
So here,
What?
so we can subtract 1 from both sides, which will tell us that negative 2x squared is equal to 7. Then we can
Square root. Oh, I think about it.
divide by negative 2, which will tell us that x squared is equal to 7/2.
Then you square root.
Any questions on this here before we do the next step? Because I know I went a little fast through that.
They all know.
Yeah, we understand.
Now we can square root both of these here. Square root of x squared is x is equal to plus or minus. And again, so the square root of 7/2, if we type this into the yellow calculator, you'll need to type it in as the square root of 7 over the square root of 2, break that apart. And if we do that, it'll tell us that it's the square root of 14 over 2. And we'll get more into this, rationalizing these fractions, when we get into the radicals equations.
Okay, I got it now.
Any other questions on this here?
No. Yes, I do understand.
So let's look at this one here, because this will be the last one we deal with square roots, and the last problem we look at today.
Okay.
So the first thing we'll do is divide both sides by 2, because these will cancel, telling us that x minus 4 squared is equal to
-5.
-5/2. Okay, so we good with this first step, yes?
Yes.
Then what do we do next? We
Hold on. Look.
is the set of parentheses,
Square root cancels out.
because here, since we have a set of parentheses square that's by itself, we can go on and square root both sides.
So then
These cancel. X minus 4 is equal to plus or minus square root of -5/2. Second square root alpha y equals
Do we have to have the -5/2, or can we just have 5/2 since it's already a plus or minus?
-5/2. We still need the plus or minus, and it gives us what?
no real number.
No real answers. So this here has no real. So there are some that we can't solve at this point. We will be able to eventually get an answer for these, but just not at this point. We're going to pick this up from here tomorrow. So we'll finish this up tomorrow.